So here we have a little thing I printed to show how the lengths of links and servo horns and so on and so forth will change what happens at the output of the servo versus where you're connecting it. So for this particular setup, I set up a master and a slave. Now the master will be your normal servo that you will have on your RC, and the slave could be anything. It could be the steering on your car. It could be something that you want to move. It could be the rudder on your boat. Regardless of what it is, the physics of it will remain the same no matter what setup you have. You just got to remember a few things before you set things up. So this is basically straightforward setup. On the master servo, we're on the outermost link point, and on the slave, which could be again your steering knuckle, your rudder, anything that you're going to be moving with your servo. So again, outer point of the servo horn, outer point of the servo horn. So that's pretty straightforward. So if I move it, I get exactly the same result as I'm putting in. Right? The only one thing to remember here is that the farther away you are from the center, the less power you have on your servo. Now, when a servo says 23 kilograms per centimeter, what they mean is 1 centimeter away from the center of the servo, or the servo output, is where you're going to get 25 kilograms of power. So if we measure 1 centimeter, so here is the point where you would get the actual measurement from your servo specs. So if this was a 25 kilograms per centimeter, this is where I would get 25 kilograms per centimeter. And it exponentially reduces the power as you go out. So if you wanted more power, obviously you'd have to move this in. Now the opposite side of the power is the range. If I put the link here, I will have more power, but I will also go less distance away. So if you see how far this one goes, basically traveled, it's the same amount of rotation, but it's not the same distance. So if I measure the distance here from the center, I get about 25 millimeters, but here I will only get approximately 15. So what you're doing is going to depend on what you need to do and how much power you actually want to deliver to whatever it is you're trying to move. Another thing to consider is that if I drop this link down to here and approximately, we'll say, double the power and half the range, but leave this one on the outside, let me show you what happens. So now we have the master, or the servo, pushing at the innermost link on its horn, and the slave on the outermost link of whatever it is you're pushing. So if I move this, now watch the movement here. I get this to 60 degrees. I have approximately 20 degrees of movement on the other side. If I was to put this one on the inside, again, I'd get an equal amount of movement. So again, if it's equal, you will get the same amount of movement. If the linkages are the same distance away from the center, you will get the same output as you do your input. So this will be your input, this will be your output. So push it that way, you get exactly the same angles and throw as you would otherwise. The difference here is, as mentioned before, you will have more power. And that same power will be transmitted to here. So if you needed the power, you will use the innermost link on your servo horn. But if you needed more distance, you will use the outermost. Now, if we changed it and we did the opposite, and we use the outermost on the master, on the master servo, if you're outermost, you get less power and more throw. If you're on the innermost link, you get more power and less throw. Now, the opposite is true on the secondary item or the slave item. On the slave item, if you're on the innermost, you'll have more throw and less torque. And if you're on the outermost, you'll have more torque and less throw, which is what we see here. So if I push this to 45 degrees, I get almost 90 degrees here. So if you really needed to push something far, you could use this method. Now, there's a problem with this. If you push it too far, you're going to get what's called binding. Now, you see what happens is the link is almost straight with the servo, with the secondary item, and it's pretty much locked. I can't turn it back. So I got to unlock this, and then I can move it back again. While you can have a lot of movement using this method, you have a limited amount of throw you can use here, because otherwise it's going to lock. See? Now it usually locks on the return. The opposite is not so true on this side because it's pulling and not pushing, so it doesn't really get locked into place. Now, one of the issues that I've seen online, particularly on Facebook, about a setup that someone was trying to do on their modified custom RC, was that they had their link, their steering servo, and their steering knuckle set up in this particular way, where the link was on an angle. And if I throw this even 45 degrees, if you're setting up a custom steering system and you want to get as much steering and as much power to your steering knuckle as possible, try not to do this. Especially when your linkages are opposite of each other, what you need to do is have the link more on the other angle so that you can have a better control and you will maintain power. Whereas if you are on the opposite angle, you will have less throw because it just cannot go as far. So let's say I keep this here and I bring this down to there. You can see there's much more throw. So the ideal location, if I keep this at 45, the ideal location, if you can see the servo, gets pushed and then starts going back. So here we have just over 45 degrees. And if we keep pushing out, it keeps moving and turning until we have somewhere around 15, 17 degrees. So if we stop this at our ideal location, which is the maximum amount of throw, which is approximately there. And we move this back. You can see there's a little bit of an angle here. I hope that was clear. Tried to explain it as well as I could. If anything's not clear, just shoot me a question in the comments below. And again, I'll see you guys later.